All right, we're trying another ed puzzle here, people. Guess what? This ed puzzle is going to go with worksheet number 3. It's a worksheet that looks like this. Now, there's a couple of problems on this worksheet that are still from worksheet number 2. Like, look, that's really from worksheet number 2, right? That's really from worksheet number 2, okay? Shoot, that one's from worksheet number 1. But the rest of these problems, bip, bap, boop, boop, I'm going to show you how to work right now, okay? So worksheet number 3, again, the same information. The number you're given over 1 times 1 over the proper number gives you the number of moles. But this time, we're not going to be dealing with grams. We're not dealing with grams. Nope. We're dealing with atoms or molecules, okay? Now, let's pretend that we have a mole of sodium, okay? Sodium is a soft metal. We're going to say we have a cube of this soft metal, okay? And it's sitting on a scale, all right, on a digital scale. And we have 23 grams of it. So we have 1 mole of sodium. Now, what does that mean? It means if we zoomed in with a magnifying glass on this sodium and we could see all of the individual atoms that make up this 23 grams, that it would take, that if you looked in there, there would be 6.02 times 10 to the 23rd atoms in this sample. This many atoms, okay, of sodium weighs 23 grams. Here's the table. There's the rest of the table. This many atoms of sodium are that's the number of atoms that make up this cube of sodium. That's crazy, but it's true. It's as close as we can get to being accurate. 6.02 times 10 to the 23rd. Now, if we know that there's 6.02 times 10 to the 23rd atoms in 1 mole of anything, then we can make some really simple calculations. What if you had 1.5 times 10 to the 23rd atoms of anything? I'm going to write magnesium, okay? But I could write magnesium, I could write sodium, I could write potassium, I could write phosphorus, I could write sulfur. I could write anything right here. How many moles would I have? Now we're going to go back to this very original problem. The number we're given times 1 over the proper number equals the number of moles. So what is the number that we're given here? That's right. We're given 1.5 times 10 to the 23rd atoms. All right? Now, 1 over times 1 over the proper number. What is the proper number for the number of atoms that is in 1 mole? That number is 6.02 times 10 to the 23rd. I literally just showed you that, right? So, remember, I was on this picture right here. That's how many atoms are in 1 mole. So, we can figure out how many moles we have by counting the atoms. And we're going to have 1.5 times 10 to the 23rd out of 6.02 times 10 to the 23rd. That'll tell us how many moles we have. Now, look, I told you in the stream, in the Google Classroom stream, to download a calculator that has this EE button. If you look in the stream, I even named the specific calculator. You can download it to your phone or to your computer. It doesn't matter, all right? This is how we're going to enter times 10 to the 23rd. Watch this. 1.5, and then I hit this button, EE. EE means times 10 to the, and then you hit 2, 3. 1.5 EE 2, 3, and I'm going to say over or divided by 6.02 EE 0.23 equals 0.25. 0.25 moles. So if you had 1.5 times 10 to the 23rd atoms of anything, you would only have a quarter of a mole. If you only had 1.5 times 10 to the 23rd atoms of this, you would only have an area about 1/4 of it. If this is a cube, you got to imagine this is three-dimensional here, okay? I'm trying to take up 1/4 of the cube. That's kind of hard to do. All right, let's try some more. Like I said, these are problems that are like on worksheet number 3. What if you had 9.9 times 10 to the 24th atoms of zinc? How many moles would you have? Okay. Given over 1 times 1 over the proper number equals the number of moles. Let's mix it up. What's the proper number of atoms in a mole? Yep, 6.02 times 10 to the 23rd. What is the number we're given? Correct? 9.9 times 10 to the 24th. Now I'm going to wait on you to give me this answer. What is this answer? Okay, let's see if you're right. 9.9 times 10 to the 24 divided by 6.02 23 equals 16.44. Let's try that one again. 9.9 24 divided by 6.02 23 equals. All right, 16.4. Something about that didn't look right to me. 16.4 moles. I'm going to give you one more. Now, we don't have to just be talking about one atom. What if we had 7.4 times 10 to the 23rd compounds, so we'll say compounds of NaF, of sodium fluoride. That would be equal to how many moles? See, I can't say atoms because I'm talking about the entire compound, the sodium fluoride together, right? All right. How many sodium fluorides would it take to make 1 mole? Well, that's our proper number. Again, the number given, 7.4 times 10 to the 23rd. What is the number for a mole? How many compounds are in a mole? 6.02 times 10 to the 23rd equals blank moles. Once you calculate that for me, what answer goes here? All right, I'll do it with you. 7.4 EE23 divided by 6.02 EE23 equals 1.22 or 1.23, or we'll just call it 1.2 moles. So if you had this many compounds of sodium fluoride, you would have more than 1 mole. This is how many compounds are in 1 mole. You would have 1.2 moles. All right, people. Good luck with this.